welcome to my blog. This will be the final video on the neon sign, and in this video I'll show you my trip to Outline Displays where I met Chris and Martin and videoed them making the glass tube work, filling it with neon gas, everything all the way through right up to fitting it onto the sign, showing you the sign completed. I hope you enjoy this video. How has glass differed from nowadays to what it used to be like? You were saying about there was lead.
Yes, it's mainly lead free now, whereas quite a few years ago now it used to be all a lot of soda glass and lead glass, but now they've put it all down to just basically lead free glass, and it melts quicker. Lead glass, you've got to use oxygen because it blackens the tube with lead, but with lead-free glass it doesn't do that.
You're marking it with a pencil?
Well, we mark it with a China graph to mark out where we need to put the turn back or the bend. Basically a pencil which would write on glass.
Right, okay, right. And how do you actually break it? Do you have to scribe it all the way round, or do you just
you basically
mark it?
I can show you that.
Here's a quick demo of that, because I caught you doing that for a split second.
Basically it's just a couple of marks, and then you pull and snap.
Oh right, okay. And it just follows the break round.
Basically, yeah. You just get a clean break.
Yeah.
When we're doing joins, where we need an absolute clean break, because when you've got the letters bent, we have a mark where I'm going to join it. I score it, which I can show you now. I score it a few times because we use a hot wire on this, just so we know we are going to get a clean break. Which is...
let's see that working. Interesting.
Because if you try to do like I did earlier and try to pull it and break it, then you've always that chance of breaking the letter what you've already made. Where this is just... and then you hear a little crack.
You heard a little chink then?
Yeah, little crack, and then it's done.
Yeah, fantastic. So we're getting on well. So we've got all of Trev's written out now. Yeah, we've got Trev's done, and it's just a matter of joining it together and then electroding it. Right. So the only other thing we didn't discuss was when you're heating it up. So you heat it up. How do you know when it's up to temperature so you can start?
There's no set temperature. It's just the feel of the glass.
Yeah.
You know, you can't over melt it, or if you under melt it, you're not going to bend it properly. If you over melt it, then it can you can lose control of it.
Yeah.
It's just that in between bit.
Yeah.
And then you know, well, basically it's just experience.
Yeah.
When you know you've got there, then you can do whatever bend you need.
Yeah. And I noticed you were doing the bending and then coming over to the drawing and offering it up. Can you bend it once you've got it to the drawing? Is it already started to set?
No, you've got to sort of judge it in your head. You check the drawing out in your head.
Yeah.
And sometimes you glance back just to make sure where your bend's going.
Yeah.
You've always got your mark on your thing, so you know where that's going, but it's the angle of the bend or anything like that.
Yeah.
And then you just basically judge it, and then it starts to go off as soon as you take it out of the flame. It starts to cool, which then you can't get much movement. You've got about 2 or 3 seconds of movement once you get it near to the drawing.
Yeah.
And then if it's not correct, you just take it back to the flame.
Warm it and go.
Again, and then just alter it.
Yeah.
Like
what was the laying down on this map for?
That's
in
just
between?
to make sure all your sections are flat.
Oh, I see. Yeah. So you know
it's just a bit of gentle pressure.
Yeah.
You can do it by judgment with an eye.
Yeah.
It's just to make sure
that it's going to nice flat.
And everything's all flat, and then that's it. Basically.
Okay. So you don't use oxygen anymore. You're saying about using the oxygen?
No, I've never used oxygen.
No.
Mainly, as Chris said earlier, it's mainly a lot in France and America, but we don't use it here. I've never used it in a long time.
Yeah, because they use Pyrex.
Yes, they do use Pyrex, which is a lot harder glass.
Yeah.
And you need a lot hotter flame to melt it.
the supports on to support the glass. And just clip in supports. They used to be made of porcelain with brass studs to hold them in. But use these much quicker, much easier supports now. The transformer is fitted in the back. And nearly ready to go. Insulate between the electrode and the metalwork.
Basically, we just mark where the electrodes are going to go. These are right-handed electrodes, so we just put a little cross where I need it to.
Right, okay.
Need it to sit. Well, that's bent up already, so I had to bend that up so I could get it, join it in, so it doesn't go across that.
Right.
And then we choose the electrode which we want. This is 10mm glass. We use a 30mm electrode. Got 30mm, 50mm, depending on the size of the glass you're using. And then we've got 80mm. So you've got like 3 different types. These are a larger electrode, but we don't use it. Here's a 120mm electrode, but we don't use that anymore, because we don't make large glass anymore. That's used for 25mm diameter tubing. So
Yeah, big stuff.
yeah, which is probably something like their 20mm diameter up there, but we don't do many of them anymore now. And it's the same procedure with this as we did for the glass. We just store it off and then hot wire it to chop off the excess. There's a little crack there, very faint that one. And this is actually the tubulated electrode, which we put another stem on, like that, to join on, so we can join it to the pump. And we weight the glass down so you don't get any movement in it. Put our blow tube on. So keep the pressure inside the tube so the joint doesn't collapse.
You've got to watch where you stand round here.
Yeah, so Chris has burnt his leg a few times, so have I. I've got a few holes in the black of my jeans. Everything, we warm up slowly first. If you put a direct flame sometimes on glass, it can just shatter. Pulling that off at the desired spots. Just to tidy it up. coil so we can join the electrode. Make sure the electrode's straight. Then we anneal it to get it to all round about the same temperature, and so if it cools down when you've just been having a sharp flame on it, it can crack when it's cooling down if you don't anneal it. Basically you're bringing it all to the same temperature.
Right, okay.
It's a bit like when you're in a kiln, when they're doing pots, they bring it all up to a high temperature, and then so every part of it cools down at the same time.
Yeah.
Obviously we don't have to do this much because you want to heat it that much up.
Yeah,
So.
yeah.
And then we put the stem on it to join to the pump. Basically it for the first side, and we have to let it cool down. Once you've heated it up and once you've melted glass, you don't put it down on a bench, it has to be kept cool, otherwise it will cool down at a different temperature.
Right.
It will crack.
Yeah.
So basically leave it over the edge of the bench to cool down. Current through the section when we take it down to a vacuum. But before we do that, at certain places, especially on tubes like this, when glass is quite close to one another, we need this, which is called mica, and that stops a current. Because obviously a current wants to go in a straight line.
Jump across?
Yeah. So this prevents it, the current, which if it jumped across it would cause an arc which would wreck your tube.
Yeah.
It would just punch a hole in it. It only needs to be in the really close spots. And then we're good to go. And the next stage is...
Are we going to see anything here while you're doing?
Yeah, that is quite high voltage there.
Oh right, okay.
So you don't want to get too close. And then once it gets to a certain point, it will light up with just air inside it at the moment.
So that's just air?
That's just air.
Wow.
And what that does, starts to get the tube hot, which cleans any impurities out inside the tube. And just so I can show you, just turn it off for a sec. So we know how hot the tube is getting. It's usually around about 300 degrees Celsius. And that piece of paper will tell me how hot the tube's getting.
Is it my eyes? Because all the while it seems to be changing colour.
Yes, that's because the temperature's going up. It will start to go a bluey colour.
And eventually you'll see the electrode shells start to glow. They go up to cherry red.
I can see them now, yeah.
And you see the paper is starting to go brown.
Yeah.
And all we're doing is slowly increasing the current. To get the electrodes and the paper burning.
So some mad scientists then you've got
And
here.
that's
Frankenstein stuff.
Yeah.
And we'll let it cool down to a certain temperature, which I can't remember at the moment.
It's about 150 C.
Yeah, I do it by feel. That turns the power up,
Right, okay.
and then this is the vacuum gauge. When we're pumping, it's usually around about 4 to 5 when we get in the tube hot. And then it will go down to more or less 0. And that's a piranha gauge. That is a fine vacuum gauge. And that tells me if there's any leaks in the tube or anything like that. And then we've got the turbo pump, which takes it down to even greater vacuum. And then we've got the gases what we use. We only use 2 gases, and that's argon or blue gas, which is a mixture of argon and neon. They're usually about 25, 75.
Yeah,
And then
75% argon,
yeah, 75% argon and 25% neon. And neon gas itself, pure neon, which we'll be using in your tube.
I don't know, there's so much in it. Never use it.
I'd say this takes about 5 minutes or so for the tube to cool down. Then all we do next is take the stem off. complete, apart from painting and aging.
Spot on.
We put it on to burn in now. We put it on a slightly bigger transformer than we would normally run it on, so it runs a little bit hotter. And that completes the burning in process. So this takes from anything from 10 minutes to a couple of hours. You see it's dim at one end, well, that will eventually burn in, so the whole thing will be the same brightness.
Right. Yeah, because it looked very pink over there, the one end.
Yeah, it's just
in comparison, yeah.
You say it just takes a little while to age in, that's all, and
It's already
Yeah,
changed.
it's already changed.
Sometimes they'll be completely pink, depending on the temperature and what have you.
or how old the neon gas bottle is.
And that is all there is to it.
Very straightforward.
You can tell when it's aged in as well. You can't see it through there properly, but if it's not aged in, it will look blue through the blue.
Right.
But
Okay.
it will look all the same colour.
Yeah.
If not.
On the panel. Probably a little bit careful with the lettering, because on the bends that's the weak spot on the neon. But,
It doesn't want to bend anymore.
no, exactly. It does
My bends aren't weak, Chris.
No, they're not. No, they're very good. But that is the weak spot in the glass, because it's slightly thinner, because it's stretched
Yeah.
as it goes around. But the lead-free glass that we use now is much less brittle than the old soda glass.
Oh, okay. Yeah.
The soda glass was a bit temperamental, shall we say.
Soda glass is very temperamental.
Yeah, I mean, you could have a section that's been made for 3 days hanging up, and all of a sudden it'll just fall apart.
Yeah.
Because it's got a stress crack in it.
Ugh.
But lead-free glass is
Stable.
much more. Yeah, it's more sort of malleable, and it is more stable.
So it was. Weren't you saying something about oil slides or something? You said to me.
Yeah, that's where I got into it originally. I mean, we were making liquid wheel projectors and that sort of thing for effect lighting for nightclubs and discos and all that sort of thing in the 70s. And I was working for a company using neon for nightclub installations in the late 70s, 78, 79. And then I started my own business, carried on installing neon into nightclubs mainly, and all sort of controlled neon and that sort of thing. And the company I was buying the neon from went bust, and I happened to walk in on the right day and bought all the equipment and gave the guy a job. So it all happened from there really, and then we were operating in Bromley for a period with 3 glass benders eventually, and sort of really busy at that time. And 25 years ago, moved in down here. I didn't have a glass shop for a while, and then had the opportunity to set up again, so we did that, and the rest is history really. So been manufacturing neon for going all over the world ever since, and we do a lot of exhibition work and that sort of thing, which gives us quite a broad spectrum of things we can do, and we specialise in controlled neon, so sort of flashing in sequence and that sort of thing. But even taking neon to Las Vegas, which is
Brilliant.
yeah, it's for an exhibition stand, which we took that over and installed it over there. So yeah, all good. One more to go. We'll have to do a baking bird one next.
Wow, look at that. Wow, that looks absolutely incredible.
You just need to go. You need to go a little bit lower with your sign, and over to that way a little bit with your arm. Your body's in the way of.
How's that?
You move your body. No, your whole body. That's it. That's it. Perfect. Yes, just about got it all in.
What do you think? Is that epic or what? That's epic.
That is epic.
That is epic. What do you think, Martin?
Very good.
Very good, yeah, very good.
Stunning. No, it looks good.
I think we got the desired effect.
Okay.
Fantastic. Well, thanks very much for watching. I really hope you enjoyed that video. Also, massive thanks to Chris Cadle from Outline Displays who helped me build this amazing neon sign. Chris's contact details are in the video description if you'd like to discuss your own neon sign project. Before I go, I'd just like to say I'm giving all this stuff away on my Instagram account. A link to my Instagram account is in the video description. Simply follow me and then comment on the post I'm about to put on. You could be in with a chance of winning this stuff. All you got to do is comment on the post and I'll pick a winner at random using a, I don't know, random number generator, something like that. Anyway, until next time I'll be showing you how I built my welding trolley. So that'll be interesting to watch. And until then, I will say, bye for now.